So in this screencast, I just want to give a quick update on some of the testing that Ocean Leadership is doing along the linked data pattern approach for exposing ocean drilling data. So just a brief background history on this. What this is involving is loading deep sea drilling data, ocean drilling program data, and international ocean drilling program data into a Sparkle endpoint. In this case, we're using the Virtuoso server. This is allowing us then to make queries against that using Sparkle, both for third-party desktop type applications and for web-based applications, and there's some other screencasts that are covering that. We're also working on some vocabularies then to include in this whole mix so that we can begin to do searches against concepts like lithologic concepts rather than just parameter type searches into the data. So the primary reason that we're doing this is that we really want to expose this deep sea drilling data in a way that makes creating applications far easier for the science community and for the general community, both for science efforts and for education and outreach efforts. Also, there's value to the various implementing organizations moving towards a common data model and common query language for exposing their data. So this would be the Japanese, US, and European implementing organizations. And this is viewed as a potential pattern for that. So in this example, what I'm doing is, in the past we've been focusing primarily on loading data into the Sparkle server and working with it through Sparkle calls and doing some other things along those lines and establishing vocabularies. What I wanted to look at, though, was some aspects of consuming that data in a more generic environment, because as we begin to get that data loaded in, the question is going to come up, okay, so what is this doing and how is it improving how we deal with our data? And so I was particularly interested in taking a look at the Simile Exhibit package and seeing whether or not it can consume some of this data and expose it. Some of the things that Tetherless World is doing and others in terms of consuming data.gov data, transforming it and consuming it through those environments is very interesting to me. And I think parallels some of the things that we're doing with the deep sea drilling data. When I first looked at Exhibit, there does exist some early approaches to consuming directly RDF data. I found that using those was somewhat problematic. So I switched then to the JSON environment. When you're, of course, accessing these data sets over the network, Simile Exhibit really wants to see this coming back as JSON-P with a callback method in it. And currently, Virtuoso is simply exposing this as JSON. So I created a very simple proxy then that allowed a Sparkle query and a callback name to be sent into this proxy. This is called the Virtuoso server. Collected the JSON, converted it into JSON-P, and sent it back up the stream. It would be nice if Virtuoso would actually allow JSON-P directly, just providing a callback method name and then wrapping up the JSON that it creates now and doing that. But this worked rather well. I'd also like to give a quick shout out to my friend Josh Reed, who really helped a lot with and wrote basically the callback method that converted the Sparkle JSON structure into the JSON structure that Exhibit was looking for. And we'll go into just a little bit more detail on that in just a bit. But real quickly, let's go ahead and just take a look then at this demo. So I'm running this against localhost. This is making a Sparkle query call out to the Ocean Leadership servers in DC, however. This is just using the framework from the Simile Exhibit environment, that is the Senate example. And so I've just modified that, in this case, to work with 4M data. This is foraminifera data, this is micropaleontological data. And this is actually looking at the 4M working group, planktonic 4M working group data. So in this case, I've called back the RDF graph, or actually we've done a Sparkle query through a URI, and the results of that were sent back in JSON-P because we made that query through our proxy. We then used a callback method in the JavaScript to convert the Virtuoso JSON structure into the Simile JSON structure. At that point, there was really nothing more that needed to be done. We loaded this data into Exhibit. We told it which elements we wanted to actually be our facets. So we can begin to click on our facets down through here. As you can see, dynamically break this down into just a few of these things. We then used their lens mechanism to create a view into these resource URIs. And these are actual then resource URIs. So if I were to take one of these and request it, we would actually see the data that's coming out from this. And I could request this in RDF as well. And this codices application is following the linked data pattern. So this is a dereferenced URI. So we threw 3 redirects from that down to our content negotiated URI that we want for this. It's also available in RDF, and this page is RDFA, XHTML with RDFA as well. So we can go back, we can reset our filters, we can do the kind of standard faceted type browsing into this RDF graph that we would expect. Now we take just a quick look at what we're doing here. We're not allowing dynamic parameter queries at this time, so we've just got a simple href that calls out to the codices service here that is in fact doing our proxy call, so we're getting our JSON-P rather than just JSON back. You'll notice here we're doing application type JSON-P, and then we have our callback methods. This is the Sparkle converter method then that modifies the Virtuoso JSON structure to the Simile JSON structure. And then at that point, we're passing it on through into Exhibit, into Simile Exhibit, and just using the standard structure that's in there for declaring out the facets and declaring out the views that we want into this and the lens type structures that we want into this as well. Now, we could also do this with geospatial data. In fact, an example done with some of the age models is here. And this is a little bit simpler, but we can actually begin to break this down and facet view into this and add some together and see the various age models that are associated with this. This is a test just simply done to make sure that we can deal with the geospatial lat-long data that's coming out of our Virtuoso server and incorporate it into the Simile Exhibit environment. So the basic upshot of this was to test, right? We're loading this data into Virtuoso. Virtuoso is exposing the JSON data in accordance to the W3C Sparkle JSON structure or approach. We did have to address an issue with Simile Exhibit wanting JSON-P rather than JSON in order to do the callback and then modify the JSON into a format that Exhibit likes. As I mentioned, there is some work with Exhibit directly consuming RDF. I think that's somewhat new and still a little bit problematic at this time, but it would be nice if either Exhibit could directly call RDF or if Virtuoso could directly return JSON-P. However, I was very impressed with the results. There's very little modifications beyond the massaging of the JSON structure through the callback methods, and that was actually well supported within the Exhibit framework. I was very impressed with how easy it was to then drop this data into that package and begin to visualize it. There's some other things that we're looking at in terms of some of the timeline stuff. You saw some of the geospatial stuff that we're just working on. But the main thrust was, can we in fact expose our data from Ocean Leadership and from the USIOs at TAMU and Columbia University at Lamont Doherty? Can we expose that data in a way that a third party could come along and structure a query into that data? It's a simple Sparkle query into that data. Extract that data and then use it locally. And I think that the example with this particular package has gone a long ways towards showing that that is indeed possible.